Can you all still see my screen? It's now chem. We just want to finish the last part of preparation of salts in a few minutes and we'll be done. Just a few more minutes. Okay, guys? It's chemistry. Khami. Right. I want to go on serious supersonic speed for this subject, okay? Because it's not hard and I want us to move very fast. Okay? I want us to move very fast. And do as much work as we can, make ourselves ready. So you at some point you're going to see that these subjects are not hard. All these things that we are doing, nothing is really hard, students. You just have to be consistent, okay? And push until you're on a level where you understand everything and you just start polishing yourself until, okay, you get to a point where you're confident of yourself. You're confident in yourself for anything that comes. So, yeah, I think after the weekend, this weekend, we are now going to start putting the other subjects as well into the equation. So, I'm going to have to do a lot of things this weekend, definitely, so that I open space going into next week for the other subjects that we've been neglecting. So we need to kind of give them a lot more attention. Are we together? Everybody? Guys? Mm-hmm. So we've made a bit of space for other subjects. We'll try to start putting them. Let's just make sure we finish the hot things for these subjects, and it makes it much easier because if we have done 17 to 21 for bio, if we've done chapter 6 and chapter 3 and chapter, for physics, then we're left with things that we can cover in no time at all. And I'm confident in that. I know that you won't need too much to cover. By the time we get to September, of course, we should be done with everything. So now we need to push a bit of those other subjects we are neglecting. So we'll see. I'm working on it. Now, anyway, of course I know that time is limited, so I'll only do so much, and I'll use the other things like videos and stuff to push. Right. We have 12 chapters. We are doing chapter 7, which is acids, bases, and salts. That's the one we are trying to finish. Acids, bases, and salts. So there are chapters that I want to try and make sure that you guys are good at. Okay, though the chapters that I want to make sure you're good at acids, bases, and salts. I want to make sure you're good at electrochemistry, chemistry of the environment, organic chemistry, chapter 12, experimental techniques. If I can push those chapters as fast as I can and make you people very good at them, then I'm going to be the happiest man ever. Here we are looking at the last part, which is preparation of salts, and then before we do the questions, all the questions, I'll do a summary for you, showing you the things that I wrote for you. So you can know everything in one go, and then we can do questions together. And of course, I give you questions. So yeah, your mind will be strained a bit. I'm going to be making sure you do questions with me, not just I do alone. Okay, so we are on salts, which is what the syllabus wants you to know is preparation of salts. If you go to the last lesson we did, you see I kind of redid the definition of salts and stuff. Because of time, I'm not going to waste time on that. I'm just going to talk about preparation of salts. And I said, in simple terms, when we say we are making a salt, we are making an ionic compound. Okay, when we say we are making a salt, we are making an ionic compound. Sodium chloride. This is a salt. Can you see this? Just any time when you have a metal and a non-metal, then you're going to get a salt. Okay? Even if you say magnesium bromide, whatever you have, anytime you have a metal and a non-metal together, you have a salt. Are we together, guys? Please respond in the last few minutes. Come on, let's just push. We are not far from finishing. Everybody? Hello? So now, what I told you last time was that the reason why we are making salts is, listen, there are salts that you can mine. Okay, there are salts that you can mine, but there are salts that you cannot mine. You have to make them in a lab. You have to make them in the lab. You say to me, why are we making salts in the first place? Because salts are useful. Okay, we are preparing salts because salts are useful. These salts, they're very useful. We can make many things. Fertilizers, I always tell you. Fertilizers, we need salts. To make batteries, we need salts. To make cleaning products, okay, cleaning products, we need salts, right? For healthcare, we need salts. For fungicides, to kill fungus, we need salts. All these things we need salts. Okay? For fertilizers, the salt I told you, ammonium salts. So you can say NH4 salts, ammonium salts. For batteries, you need Li salts, lithium salts. For cleaning products, you need sodium carbonate. Okay? Na2CO3 salts. Okay? For healthcare, you need magnesium sulfate. For fungicides, you need copper salts. This is magnesium sulfate salt. It's a salt. Of course, it's a salt. Because you have the metals and the non-metals. So salts are important. To make soap, just say cleaning products, to make batteries, to make fertilizers. So we need salts for fertilizers, for batteries, for cleaning products, etc., etc. So definitely they are useful. We need them. Now, I said some of them, we can't mine all these things. So what we're going to have to do is prepare. So we should know how to prepare. So when we are preparing, we ask ourselves, the salt that you are trying to make, is it going to be soluble or is it going to be insoluble? And for salts, when we are working with them to know if they're soluble or insoluble, we use solubility rules. So if our solubility rules tell us that the salt we are trying to make is soluble, then that is when we had the methods that we started last time. To say preparation of soluble salts. When you want to make soluble salts, there are 3 ways to make soluble salts. Okay? There are 3 ways to make soluble salts, but all 3 of them will be using a reactant that is number 1, solid, number 2, insoluble. So we use reactants that are solid and insoluble. Then we are going to add them in excess to an acid. So we take an excess solid insoluble reactant. So when you are preparing soluble salts, you are preparing a salt that dissolves. Okay? For soluble salts, use solid insoluble reactants in excess. Now, what reactants can be used? Okay? There are 3 reactants that can be used to make or produce soluble salts. Okay, 1 metal. Okay. So you're going to say excess metal. Why metal? It is a solid. All metals are solid except for mercury. Okay, at room temperature, like right now at this temperature, you'll find all metals being in their solid form. So it is a solid, and okay, they are solid. Metals are solid, they are solid and insoluble. Metals are solid and insoluble, but they do react with dilute acid. Number 2, you can use excess insoluble base. We know that naturally the bases, a lot of them are insoluble. Naturally. We know that. Okay? Oxide or hydroxide. Do you remember that chops, oxides and hydroxides are naturally insoluble? Do you remember that? Except when they meet group 1 and group 2. That is when, and ammonium. So excess insoluble oxide or hydroxide. Any, but not for group 1, group 2, or ammonia. Because these things end with ide. So group 2 will make them soluble. I'll go back to solubility rules and remind people we've forgotten. So, but we pick any oxide you want, copper oxide, whatever oxide, but don't take anything from group 1 or group 2. Here, you. Okay? Other than that, it will be an insoluble base. You make it excess. Okay? They would be solid and insoluble. Are you telling me, said, that copper oxide is a solid? Yes! These oxides are the rocks, the ores that we extract metals from. When we are extracting aluminium, we are extracting it from an oxide. Bauxite, oxide, and it's a rock. Iron, hematite, is a rock. Don't think because oxygen is a gas, oxides are gases. You are gravely mistaken. Are we together? Students? Students, are we together? Don't let me down. Metal oxides are going to be rocks, okay? They'll be solid. Are we together? That's where you find these metals that we use. So the iron you see on your beglar bars had to be removed from a rock. Make no mistake about that. So we can use an insoluble base, which is an oxide, or the word base means oxide or hydroxide. A metal oxide or hydroxide. Okay? Metal oxide or hydroxide. But you use any metal in your oxide, but not group 1 metals or group 2 or ammonium. We don't want to see that on your oxide, because all of a sudden it will become soluble. Are we together? Are we together, students? Then the other insoluble thing that you can use to produce a soluble base is, I want you to say everything should be excess so that the acid finishes. Excess insoluble carbonate. That's why you learned about these 3 reactions for acids. Yeah? You learned about them when you're learning reactions of acids, so that you can study them in preparation of salts. Go and check on acids. You see them. You see the acid reacting with these things. Okay? Excess insoluble carbonate. Okay? They are solid and insoluble. Okay? Okay? Any but not group 1 carbonates or ammonium these two, but any other carbonates are insoluble. Rocks, right? So we know that we're going to have your acid in your beaker, then you add this, then you make them react, then you filter off. It's just so easy. Do you know, it's almost like a joke. Huh? You take your acid, you put in your beaker. You take this, either you're going to add the metal or the base. There will be a base, will be a rock. This oxide will be a rock. You throw it into there. Or you're going to have your carbonate. You throw it into there. All of them, you're going to add them to acid. Then they start reacting with the acid. Then you filter. Because they're going to be in excess, isn't it? So because they are in anything which is in excess, take it out of your mind that something which is in excess can finish. Because then the word excess is meaningless. The word excess is to say that it is too much. You are doing things in excess. You are doing too much. You are eating in excess. I don't know, wherever the best word to use. So excess is too much of something. So if we are putting metal in excess, it is more than what the acid requires. These guys, we are reacting them with acid. What we know is that when an acid reacts with these guys, we get a salt. Surely we know reactions of acids. Go and check the last lesson I did them at the beginning. You must know those reactions of acids because you need them now. So you react with the metal, you get a salt and hydrogen. You react with the base, you get a salt and water. You react with the carbonate, you get a salt and water and carbon dioxide. But the salt is there. That's the one we want. And that salt that is being produced is soluble. So the insoluble one, we don't even do this. We're not even going to do this in the insoluble. If we want to make a salt which does not dissolve in water, we won't even do this. When you see us using an acid, we are going to make a soluble salt. We add these guys in excess so that they finish the acid. The acid must finish. But these guys will remain. Now, the good thing about these guys is when they remain, they are easy to remove because they are in solid form. So we just filter them away. Then we take that acid and we are going to evaporate the acid is no longer an acid, by the way. What remains is going to be the salt. What remains as the filtrate is the salt dissolved in water. Acid is finished. Salt dissolved in water. We evaporate the water until the salt is now concentrated. We don't finish the water. We heat. Water evaporates. We don't finish it because if you finish the water, you melt the salt. So you do it until the water is about to finish. Then you put it on a dry place so that it turns into crystals. In other words, it dries up. Then you now have the salt. Then you can now use that salt. It was a soluble salt, so that was how you made it. You're not going to let me down. So if we're going to see how we make the soluble salts, the preparation, let's say preparation. Let's put preparation methods. Okay, we are preparing a soluble salt. Please, man, this is a soluble salt we are preparing. That's the only time we use one of these reactions. What are we reacting with? An acid. And what are we using? Solid things that can react. So the preparation methods, we are doing number 1, excess metal. We want to see the steps. Of course, we're going to say plus acid. So we are putting, write small things. We need 3, okay? Plus acid, excess metal plus acid. The acid normally should be dilute here when you're doing this. Then here, we said it's an insoluble base. Insoluble base plus acid. Then here we are going to use a carbonate. Of course, your insoluble one. Plus acid. Of course, the salt is going to be prepared. You know the reaction. Why did you do it if you have forgotten? But remember, I did not say excess. That's the most disastrous thing you can ever do. All of them should be in excess. Then now we can make. We know what we'll get. we'll get a salt. For all of them, here, salt plus hydrogen. You can put that in brackets because that's not the main thing. We are focusing then on the salt that is going to be produced. Here, it's what is produced is salt plus water. We're going to focus on the salt. Here, what is produced is salt plus water plus CO2. We are going to focus on the salt. That's the one we want. And can I ask you a question, class, since you don't let me down normally? What type of a salt is made here? When you do these methods, what type of a salt is made? Soluble or insoluble? Class, someone? What type of a salt are we going to make here? Soluble or insoluble? Soluble, soluble, soluble salt. Soluble. Thank you. Okay? Because it's going to, when the acid is finished and now we have water, the salt will be dissolved in the water. And that will make it easy because now we can filter away the excess, the remainder of these insoluble metals and base and whatever. We can filter them away. Then after filtering them away, we now have our salt dissolved in water. Yeah? Then we can now do whatever. Ah, man, this should be very nice. Yeah, it is. Already, let's put the methods. Let's put the steps. That is what I want to put when you put. So in here, of course, you just say add steps. Steps to this preparation. Yeah, you add dilute acid. It has to be dilute acid. Okay, it should be dilute because you are using a metal. You can cause some serious problems if you use an acid which is not dilute. Okay, you have a seriously bad reaction there. It could be too fast. It could be an explosion. Add dilute acid to a beater, then add metal slowly whilst stirring. Then 3, stop when no more acid reacts or when no more metal reacts because the acid is finished. Okay? You put acid in a beaker, you add metals, you add, and you'll be adding. When you see the bubbles stop, the metal stopping to react, then stop that reaction. Stop adding metal. You are just adding metal. Come on now. You just put acid in a beaker and you're adding metal. Where is it hard? You can write that. Put acid in a beaker, add pieces of metal, stop when the metal stops reacting, then filter the excess metal. Okay? Because we can use filtration. Okay? Filter excess metal. What does it become when you filter it? It becomes residue. Now, what goes through the filter paper? The water and the solution. Things that are dissolved in water plus the water. It's called the filtrate. So we take that filtrate. You are not letting me down. You know filtrate is not what remains on the filter paper. It's not the solid. It's not the solid. Filtrate is what makes it into the bottom of the container. Right? So we hit filtrate gently. Okay. Why? To evaporate the water. Concentrate, solution is formed. Then you leave it to crystallize. Then you, which is to dry, then you collect dry crystals. That's your salt that you're collecting. Well done. Well done. Well done. Is there any difference between this? No. Everything is exactly the same everywhere. Here, you still add dilute acid to a beaker, but the difference here is warm gently. That's the difference. And warm gently, not too much. Then now add these rocks of yours, this insoluble base. Add the insoluble base slowly. Then, when you're adding, by the way, you should stir. Stir continuously. Not when you add metal, but now you should. Stir continuously. And then stop adding and stirring when no more base reacts. When the base stops reacting, you should stop stirring. Then heat or first filter excess base. Okay, everything will be filtration. That's why, because they're solid, right? Then you heat, filtrate, and then you let it to crystallize. Heat, filtrate till solution is concentrated. 6, let the salt, or this is 7, let the salt crystallize. Then 8 is collect the dry crystals. Collect the dry crystals. Collect the dry crystals. Collect the dry crystals. So how easy is this? At some point, you're going to say the same, please. It's exactly the same for carbonate. Everything is the same. Everything is the same, yeah. The only thing is you don't add insoluble base. You just add carbonates. The insoluble carbonates slowly. You just add it slowly. Some steps are so easy. If you cram them, they're going to be hard, but if you master them, they'll be fine. You just add and stay. You stop when the reaction stops. When the reaction has stopped, and then you do filtration. Then you're going to warm the filtrate, and then you let it to crystallize, and then you are done, and then you get your marks, and then we clap hands for you. Where is that hard? Tell me. What's scary there? What is scary there, students? Surely everybody knows how to prepare soluble salts. Is there anyone who doesn't know how to prepare soluble salt here from this? Hello? Now let's do the last one. Solubility rules. Where are you? This is where you need to plan. Preparing insoluble salts. What is an insoluble salt? A salt that does not dissolve in water. How are we going to make it? Using 2 other salts. You add 2 salts that are soluble, and then you're going to get one which is insoluble, if you plan well. Are we together? An insoluble salt This is so easy, okay? It's just going to take us 5 minutes. Is a salt that does not dissolve in water. An insoluble salt is just a salt that does not dissolve in water. Now, how do we make it? Oh, let me put examples. Examples. The sulfates, the chlorides that are going to meet silver and lead and barium. So, silver chloride. We'll talk about solubility rules again. Lead sulfate, PbSO4. Lead sulfate. I think sulfate is F. Then barium sulfate. These are insoluble salts. So you can't do what we just did because they will not dissolve into water. So when you do filtration, they are going to remain on the filter paper with your metal or whatever. So, right, these salts cannot be prepared, although we may need them, but they cannot be prepared using crystallization, because they do not dissolve in water. Okay? They don't dissolve in water in the first place. Have I been heard? They don't even dissolve in water. So we use something which you're going to see even when you get to university. It's called precipitation. So let me just tell you this. When you bring A and B and react them with C and D, naturally what will happen is A will take C and leave B. B will go with D. So it will be AC plus BD. This is what happens. Are we together? Are we together? If you bring two things that dissolve in water, salts, okay, and A is bonded to B, it's a salt, because a salt is a metal plus a non-metal. You're not letting me down there. There are two things, of course. And you bring another salt which dissolves in water. The moment you put them in the same solution, this is what you're going to get as a result. Now, this will be because this will happen if there is precipitation. We said a precipitate is a solid that is formed during a reaction. So once we have a precipitate, we will see a solid forming at the bottom during the reaction. So this will happen because this will happen if B and D maybe, once they bond, they become solid and they start forming. So automatically they will leave A and C in the solution. So the solution will remain with A and C. Those are the ones that will be remaining in the solution. So we'll be just saying we get A and C plus B and D. So because B and D will come out of the solution, they'll become solid, get out. That's what we call a precipitate. So this precipitation reaction, basically, we are going to take two things that are soluble, okay? This metal should be soluble. This one should be soluble. But we should play our game very well. When we play our game very well using the solubility rules, I'll teach you, okay? We will be knowing already that B, the moment B meets D, they are going to become a solid. They will be insoluble. But when they are in other things like this, they are very soluble. But the moment they meet, they will become insoluble. So we'll play a game to make sure B will meet D. A will be maybe something which will never be insoluble. So A, whether it's meeting B or D or C, it will always be soluble. So this one, we are sure it will stay soluble. These ones, they came being soluble already. Now D is the one where the moment he meets B, he becomes insoluble. So we'll play our game knowing who becomes insoluble when. Because we know the solubility rules. So we know that we are trying to make a certain salt and we know it's insoluble. So we will prepare to make it produce itself. These ones that are soluble, we would have made them using the methods we've just studied. Now we need to make this one which is insoluble. We can't do the method which we have just studied of taking a metal, putting in an acid. It no longer works. So now we will have to do this reaction. It's called a precipitation reaction, where you take two soluble salts. They meet in such a way that a precipitate will be formed. One of them, when it meets something, is going to become solid. So we know it already. We throw it into the solution. We start to see our solid forming at the bottom. We say, yes! Gotcha, man! Gotcha! We take our salt, we go home. We know we could not have used the methods above there. They don't work because it's insoluble. The only way to make it is by taking two soluble salts. And we mix them in such a careful way, they make that precipitate, that solid there. We take that solid, we now have our salt. Whether it's soap or whether it's fertilizer or whether whatever it is, we have managed. So let's just write that stuff and the steps, then you are done. Okay, it's just a few steps. Did you get it? Students, did you get it? So method used to prepare insoluble salts is precipitation method. Or you can say precipitation reaction. We know what a precipitate is. It's a solid that is formed during a reaction and it collects at the bottom. So a precipitation reaction is a reaction which produces a precipitate. But we say it like this. And to produce that solid, we would have brought soluble things, two soluble things. Then we react them and they form one soluble substance called a precipitate. So a precipitation reaction is a reaction in which two soluble solutions react to form an insoluble solid called a precipitate. Let me just stop it there. Called a precipitate. Are we together? Are we together? Let me finish this, okay? So that you guys can be dismissed. For precipitation, I'm just kind of stamping it into you guys. For precipitation to work, reactant 1 must be soluble plus reactant 2 soluble to produce salt, which is insoluble, plus product, some other product which will be soluble. All right, really, yes. Soluble plus soluble giving insoluble. So what is the golden rule? That's the golden rule. Don't let me down. To make an insoluble thing, We need the same type of thing, but it should be soluble. So golden rule, you want an insoluble salt? Yes, you need two salts that are soluble. Soluble plus soluble give insoluble. You play your game correctly. Okay? Are we together? So let's put them as steps. Let's just put them as steps, then you're done. This is the last thing, then you're done. Step 1, prepare aqueous solutions. That means water is there. Put these things in water. Prepare aqueous solutions of 2 soluble salts. Take 2 salts, dissolve them in water. Take 2 salts and dissolve them in water. Okay. E.g., lead 2 nitrate solution. This one is soluble because it's a nitrate. All nitrates are soluble. Potassium sulfate. Sulfates are soluble, except when they meet lead and these other guys. So we know what we are doing. At the end of the day, we want this lead to meet this sulfate ion. Because we know once a sulfate ion meets lead, it will be insoluble. But we don't bring it together. We're going to bring lead to nitrate. When lead is in nitrate, it's not going to cause any harm. Lead will cause harm once you start giving it these sulfates. So lead in nitrate is soluble. It's not causing any harm. The sulfate has not yet met lead. It's with potassium at group 1. So it's soluble. There's no harm. So step 2, you have taken these 2 soluble salts. Okay? Prepare them. And they must be dissolved in water. So take them, these soluble salts, don't just leave them like that. Dissolve them in water. Okay? Then mix the 2 solutions together. Mix the 2 solutions together. Okay? And you should put in brackets to say a precipitate will start forming immediately. Okay? You start to see solid forming at the bottom. You understand? Then step 3, wait for it to form, then filter the mixture. Okay? To get your nice salt. Okay? To get your nice salt. That's the one you wanted. The residue. What that remains on the filter paper. This salt which is insoluble, which collects at the bottom. Okay? Filter that mixture. Okay? Why? To separate the precipitate, which is what you want. This time you actually want the precipitate, the solid which remains on the filter paper. So you want to take it from the liquid, so you filter. That liquid which gets, you actually don't want it. What you want is the salt that remains, the solid that remains on your filter paper. That's the salt you wanted. Step 4, what do? Wash the residue, okay, which is precipitate that remains on the filter paper, using distilled water. Hey, don't wash the salt, it will dissolve. Hey, this is an insoluble salt. What are you scared of? Okay, you are washing using distilled water is the cleanest version of water. Okay, why? To remove any soluble impurities, to remove any dirt that can dissolve, because we know that the salt itself does not dissolve, so don't worry about it. Then now you just dry the precipitate. Okay, step 5. Step 5, dry the precipitate. Anyone with a question? Is there anyone with a question here? Is there anybody who has a question on this? Students? Who has a question? Nobody? Fantastic. Top stuff. Right. Okay, I've taken the register. Well done. Well done, well done. As always, you're always doing very well. I'm proud. Just make sure you submit that assignment. I've added a few more days. Submit that assignment, please, guys, okay? When you submit assignment, you make me happy. Please. Go get yourself some time. Use the notes. Submit the assignment. Be a very good student. Because I know we'll be doing progress if you're doing that. I will try to send you questions from this as well. Not many. I don't send many. Just 5 questions or so from bio, 5 from chem. Just to make you check the notes again so that you brush it up. And then we are going to meet for maths and physics. We need to dust up that physics tomorrow. Make sure we are on a good page. Be ready. Then, of course, I'll summarize the important things as we are doing questions over the weekend. It's going to be a big weekend for us, huh? Be ready, everybody. Don't plan too many things. Make sure you're going to be home. Goodbye. Good night.